Thanks everybody, and a big thanks to Lanco for sponsoring this session, and also to APL for the invite to come here. I'm not very happy personally because I also grew up about 2 kilometres from Peter, and I'm a Fremantle Dockers supporter. So Pat's being very kind to us at the moment. You know, this time last year it was a different story, but anyway. We've just established a new centre. Our centre is conducting One Health antimicrobial resistance surveillance. We do surveillance in the human field, which has been going on for many years, and also in the animal field, as Pat's alluded to. And I work very closely with Sam Abraham, who's the new lecturer in veterinary microbiology at Murdoch University, and you'll see reference to Sam a lot more in this particular talk. Okay, so we've had some great presentations so far. There's some areas that I can quickly gloss over, but just to put a tiny bit of a different spin about it, our medical miracle of antibiotics, just to show you how dramatic an antibiotic response can be. This is photos taken in 1942, just after the introduction of penicillin. This child would have died. You can see here she's got very severe cellulitis and infection, septicemia, and just after several treatments of penicillin, boom, she's looking really well. And that's what antibiotics have been able to do. They've extended the life expectancy of humans greatly. I found this little cartoon, and it really, to me, illustrated perfectly what happens in the microbial world. We've identified antibiotics from other microorganisms, we've purified them, we've put them back in, and they're very effective at killing most of the bugs here. And this poor little guy here, a very famous song, he's the guy that's left. And the interesting thing about this is, note, they've all got their little bits of DNA in them. And this little guy's got that little red plasmid. And I thought that was very clever on the cartoonist to sort of remind us of the importance of plasmids. And I'll refer to those a bit later on. And Pat's given us a great introduction. She's really learnt well in terms of the complexity of the situation. Of course, here we've got the difference between the chromosome and the plasmid, and Pat very eloquently gave you a great explanation of that. What I just wanted to reinforce there is that the DNA on the chromosome, those are essential genes for growth and replication. The plasmids are those things you just put in your pocket to give you a survival advantage in different ecological niches. So they're non-essential genes, and that ability for them to be lost is very keen. And we're going to refer to fluocinolone resistance, a critical important antibiotic in human medicine. And Pat alluded to the fact that most of the resistance is associated with plasmid mutational changes, whereas ceftiofur or Exenil-Xceed, the resistance there, we call those extended spectrum beta-lactamases. The thing is that we have those drugs being commonly used in both humans and animals, and those are pretty much genes that are located on the plasmid, so they're accessory genes. Okay, so if we think of taking an antibiotic, it's incredibly simple. So simple that our doctors can overprescribe. Every time we go, we can say, I've got a sore throat, I'm worried about getting a secondary infection, and you'll get a course of antibiotics, you can take them, and you'll feel immediately better. And we now know that this whole development of resistance and trying to actually, teach the public about the development of resistance, it's incredibly complex, and it's almost devious in terms of the way in which these resistance genes have found their way onto plasmids and are now sort of spreading around the place. And Pat also alluded to the fact, and that's what I'm going to be talking to about our new technologies, is our current sort of gold standard method, the method used around the world to monitor antibiotic resistance. It's labour intensive, it's expensive, and it's time consuming. So it's often a year later that we're giving you the data. We're giving you the data about a year later from the material that we've got there. By that time, the problems could have already been disseminated. The horse may have already left the barn, and we've closed the door, and boom, the horse is off and racing. So we need things to be able to go in real time, which is very important. Okay, and the huge problem, why has there been this massive sort of WHO effort, global effort, Barack Obama, the UK government, everybody getting onto the antibiotic resistance story and bandwagon? Well, what we've done is we've sort of demonised the companies, and they've realised that they make no money from the development and sale of antibiotics. In fact, it costs them about $500 million, even though the public health benefit is around about $2 billion. So as companies started reducing their investment in new antibiotics, resistance level has risen, and we've got that perfect storm scenario where, oh my God, we've forgotten to be developing new drugs, we've done all the easy ones, how do we go in the future? And that's seen that massive reinvestment, and the human pharmaceutical companies have been brought back to the table. They were regarded as the enemy, and maybe their marketing in the early days were to make sales. But now they're being brought back, and I would actually say that the animal industry pharmaceuticals, we're still sort of regarded as the enemy. You've noted on the start of my presentation acknowledgement to Zoetis. I work with just about all of the animal health companies, and without their funding, for example, Sam Abraham did a postdoc with me for 2.5 years, and that was all funded by Zoetis funding, which I'll mention some results in a moment. So I'm very much an optimist. I'm about bringing everybody to the table, presenting good science, and then us all rationally going out and doing the best we can with these medical miracles. And why is that the case? Well, with that dearth of new antibiotics and resistance developing to the existing ones, some projections have been done. A big review's been done by the UK economist Jim O'Neill, and they're talking about a huge number of deaths, maybe 50 million deaths attributed to antibiotic resistance by 2050 if we don't look at the solution now. And maybe several $1 trillion in cost in that area too, which is quite frightening in that area. And we've all got a very important part to play in reducing that likelihood of that happening. And coinciding with that, our population is growing, and I like Pat's area. We're all part of the community. We've got a prerogative. Sorry, I'll move that up a bit. So I like to talk with my hands. We've got a prerogative to actually, to be able to producing low-cost animal protein, to be able to feed this growing demand. As you can see here, Southeast Asia predicted to have great increases in pig production and poultry production in India, and that's going to require more antibiotics. So at the same time we're seeing less use being required, all of those strategies to curb antibiotic resistance are going to be needed. And I wanted to put it into a very personal context. In the pig industry, we give antibiotics often in the very early stages of life. We may need to have pulse medication, in-feed medication, in-water medication to control diseases at key points. But as the animal gets older, we have less and less antibiotics. And we've seen that with surveillance. At the end of the animal's life, we start seeing antibiotic-susceptible organisms maybe starting to overcome the bacteria in the gut that have developed resistance during those therapies. And the whole idea is that as you get older, if you suffer from a terrible bacterial sepsis, even if you're young, I'll mention an example in a moment, and you're rushed to hospital, you want to know they're going to throw the kitchen sink at you, they're going to put every antibiotic in you, and they're going to want a response within a couple of hours. It's actually going to take them 2 days to obtain the result of what's actually growing in your blood and its resistance profile. So they're taking a calculated risk because every hour that you have that infection, you come closer to death or permanent incapacity. That touched me very personally a couple of weeks ago. I'd just given my antibiotics lecture to animal scientists. We have a great program at Roseworthy Animal Science and Veterinary Science. And I got a couple of days later, one of our class members developed meningococcal. She'd seen the pictures I'd put up about, the little spots of endotoxic shock you start seeing. She went straight to the hospital. She got onto antibiotic therapy straight away, and she's made a full recovery, which is absolutely fantastic. So that's the personal story. And just think of that each time you administer an antibiotic or each time you're looking after a group of animals. We've got to save animal health. We've got to look at animal welfare. But if there's any unnecessary use, we need to sort of think about ways we can curb that. And that's this call in terms of this initiative to develop 10 new antibiotic classes by 2020, but most of those will never come into our animal area. We've got to make best use of the existing drugs we've got. Okay, and I wanted to mention some of the technologies in this talk. This is a really cool one to talk about. The Longitude Prize in 1714. The biggest problem at the moment was trying to locate the location of a ship at sea. And that's where the use of longitude and latitude was developed. It was a big prize awarded, and since that time, the Longitude Prize has been given to solve the most important issue facing the human race at each time. It's going to be $10 million if somebody can come up with a point-of-care test that will rapidly profile the resistance of the organism and its identity. And I think we could use that. That's for a bedside test. If those tests become available pen-side, imagine our ability to be able to, at the moment it's anecdotal. We have a fair idea of what we're dealing with. We make a calculated risk. If we have more tools to help that could be the single biggest development in animal health coming in the next few years. And there's some people that really think they may be onto some technologies to help with that. So rapid point-of-care tests, very important. I also, Pat's touched upon, and there was a great question about the media. I've tried and tried to present good news stories about antibiotic resistance in the media. We had a big AVA, for our Zoetis project, we had a big AVA release a few years ago. Lots of press releases around, everybody notified. One journalist turned up because it was a good news story. It was just so disappointing. So, we have to be really careful about the true versus perceived risk, and always keep, trying to go back to the basics of what the true risk is. And this statement was made back in 2004. It's still the same now, sort of 16 years later, 12 years later, that we're still talking about the same issues in pig production. We've made great steps in welfare, and I think we're making great steps in resistance. We also have to remember that, this ban on growth promotants, this use of growth promotants, that was a very cheap way of actually, with bacteriostatic antibiotics, with a very narrow spectrum of activity, of allowing pigs to develop full immunity to bacteria as they have those at different stages of their life. And the challenge is on to try to find alternatives to that cheap approach, because even though the scientific evidence is a little bit out, not really there, that the growth promotants were causing a massive resistance issue, apart from the Enterococci story and avaparsin, they're now completely verboten. We've got to find alternatives that will give you just as good, better gut health as we go forward. Right, so what's that going to mean for Australia? And I've got a few little sort of caveats and things that I'll mention. And as I go through the talk, I'll go through things a little bit quicker when they've been covered already by Peter and Pat. I mentioned about that 10 by 20 initiative. All those new classes of drug will probably be only used in humans. We want to have this separation of classes. We have some shared common classes, and it's our use of those shared common classes that will be looked at very carefully. We could get some hand-me-downs, but the likelihood of that happening very soon, it could be maybe 15 to 20 years away before we, say, have a new antibiotic with a new mechanism of action for animal use only. So we have to maximise our effectiveness of the antibiotics we currently have. And we also need to find and integrate those novel strategies to reduce our reliance on in-feed and in-water medication. As we start to try to remove things, old diseases come back. Swine dysentery, huge problem. We thought we'd lick swine dysentery. As soon as we start moving out those growth promotants or in-feed antimicrobials, boom, back comes swine dysentery, and it's developing resistance to the drugs that we traditionally use to treat. We can invest huge amounts of money, as they've done in Europe, or we can be a little bit smarter about the things, as we tend to be in Australia. We have less money, less government money to do these things. So, what I'll be presenting will be some new ways in which we can probably do the surveillance a little bit better. And you may not have seen any sort of, Peter presented data on trying to measure antibiotic use. And we've got some programs in Australia. A good colleague, Dr. Stephen Page, did an estimate on all of the information he had to look at where Australia is currently in its use of antimicrobials. Peter already said that in terms of human use of antibiotics, we're sort of quite low down. We still could do a lot better in the human area. In the animal area, we're actually pretty good. The only guys that are ahead of us are some of these European countries in Scandinavia, where they have very, very different production systems. So I think we're doing incredibly well. We can do better. We can't be complacent, but we're coming from a very good starting point and platform. And I think it's going to be a trade advantage and a way in which we can get our products out to other areas more effectively. Okay, so just to touch on prudent use guidelines, I'm not going to go into these in a lot of detail, only that the WHO, what we're trying to do is harmonise, like some antibiotics are of course more important than others. And we're trying to get a first use, second use, third use approach right the way through from human through to veterinary medicine. With that, if there's harmonisation, if we're using an antibiotic that's a third choice antibiotic and we're over abusing it, we can't really justify that because it's not being used the same way. So it's just making sure that we have that same spectrum all the way through. And also to make sure that we really look at our off-label areas. Are we really truly using it off-label? Are we using it off-label because the withholding period's shorter? That's something we've got to be very, very careful of. It really is that there's no other alternative that we can use in that situation. And if we look at the antibiotics we use in pigs, and they've been divided by the AVA into first line, second line and third line, the fact that we don't use fluoroquinolones in food animals is a massive advantage to Australia. We're the only country that has legislated that. And I think we don't talk about it enough on an international platform. The only drug that we have, Ceftiofur, Exenel, and Exceed, that can't be used in pigs except under some off-label use legislation in some states. That's probably the only drug that we really need to watch for, and you'll never get Zoetis recommending its off-label use under any circumstances. That's the veterinarian's decision and at the veterinarian's risk there. So that would be the only one that's a shared class where a precautionary principle needs to be operating. Okay, and Pat's really covered antimicrobial stewardship well. All I wanted to mention is the 5 R's of that, and I put a 6th R in that: reduction, refinement, replacement, responsibility and review, and trying to teach veterinarians to be thinking about that as we go. I think we're tremendous on getting the right drug for the right bug approach here in Australia. If I told you that half of the antibiotics prescribed to humans, that they're actually underdosing because they're not weighing the person, you'd be horrified that that's actually occurring. And I think we're getting it very good, and we've got excellent records in that case. And of course, for purely selfish reasons, I'd like to put research into there. What we're trying to do with our centre is collaborate, cooperate, but don't compete. AMR's too important for us to be trying to compete with other institutes to get that research dollars to actually do the work. Okay, and if we look at alternatives to antimicrobials, and these have all been touched on. We've heard about all in, all out versus continuous flow. If you can go to a system to control respiratory disease on your farm, you're going to halve your antibiotic use entirely there. And I think the classic examples come from the low protein diet. A lot of our nutritionists don't really like that. They don't like seeing those pigs with a check in growth. But the low protein weaner diet came out of research in Europe where they removed growth promotants, then they started using more therapeutic antibiotics for E. coli, then they started seeing resistance genes emerge. And through that sort of innovation, we found that that lower protein diet, combined with other methods such as acidifiers and things already mentioned, is very, very effective. And many of these principles, APL sponsoring a group of veterinarians to develop a holistic manual, just trying to look at this whole area of disease management. Simple things. It's not innovation. It's actually doing the small things very simply and following directions that's very, very important. I've got a new project with Peter where we're looking at a brand new, very safe sanitizer as a disinfection program. And that's been shown to work very, very well for APP to prevent transmission. So a different way of using it, but very effective none the same. Vaccines have already been mentioned. Natural feed supplements that are already, say, registered in human medicine that have antimicrobial activity, that will be a big growth area in the future. And of course, more strategic use of medication so that we try to ensure herd immunity and we don't have this mixing of immune and pigs carrying the bugs with non-immune pigs and those key diseases we see, strep suis, Haemophilus parasuis, APP and other things. Okay, so the last, what I wanted to present to you is just a little bit about the surveillance work that we've done and where we think we can go in the future with novel surveillance work. And this is work we've done with Zoetis, and it's covered all of the animal pathogens, companion animal and food animal. And the baseline survey that we did, it's taken us a couple of years because we've looked at the two methods to compare antimicrobial resistance, disk diffusion and MIC testing, and looking at the agreement between the two. And at our launch of our new centre, that's where we'll be presenting the final results. But we have been presenting these results at different places over the time, and some of you may have seen that. But just to let you know that in 1 year, we got nearly 2,600 isolates from the 22 vet labs distributed throughout the country. It definitely showed us how many livestock isolates we get compared to companion animal, but it allows us to do a bit of benchmarking. And even though it's a bit of apples and oranges, here are the 3 critically important antimicrobials. Third generation cephalosporins, which we have ceftiofur or Exceed or Exenel, fluoroquinolones, and of course carbapenems that Pat's already mentioned so far. What you can see is companion animals and humans, we're almost neck and neck in terms of the prevalence of resistance, and that's a very low level. We're seeing some countries with 60% prevalence of resistance to fluoroquinolones, so I think we start from a really good low level. But in the livestock area, and these are pig and cattle isolates, we're just starting to see the emergence of some resistance to ceftiofur. Very low at this stage, and it's not spreading. They're quite discrete ones. And one of the isolates, one little isolate was also fluoroquinolone resistant, and Pat's already mentioned that at the moment, and I'll come back to that a little bit later. And very low levels of resistance to carbapenems, but it is emerging and spreading in humans. Okay, so our current project that Pat mentioned will be that nationwide survey. We're right in the middle of doing that work at the moment. And I think the pig industry, we've got balls and ovaries, guys. Balls and ovaries, I call it, because it was to take the risk to say we'll be the first industry, we've got the most to lose, in that area. And the other industries are following suit with that. So I think it's great that we're doing that. And that will allow us to benchmark ourselves against what's happening internationally. And I think it'll open up some new markets for us once we start getting that data coming over several areas. And while we actually do it every 3 years, but it's expensive. It's about $200 an isolate. It's time consuming. As you've seen, it takes almost a year by the time you get it all together and then you report on the data. We've got to have a better method of doing it. And that's where Sam Abraham and I, we've actually got a big ARC LEAF grant. That's a big equipment grant with the Australian Research Council to buy about $1.2 million of high throughput robotics. We think we can automate this process where you just get the fecal sample, goes right the way through to plating. It goes then to identification with mass spectrometry. That's about a $250,000 piece of equipment, but it identifies the bacteria for 6 cents an isolate. We then go into the susceptibility testing with robotics, and we have the ability, if we find, because at the moment we're going to see a lot of hay and maybe 1 or 2 needles as that fluoroquinolone resistant isolate, we can pull out that resistant isolate, we can sequence its entire genome, we can sequence its plasmid and find out where it came from. And I think that gives us amazing data, and we can do that whole technique for $60 an isolate. That's almost cost effective for people to be on a stewardship program or a quality assurance program every couple of months to just get some samples, send them through, and actually get a report for what you've got. Okay, so that's where we're going. Fingers crossed that we get that technology in October this year and we can move forward with that, not just for the pig industry, but for the other animal industries too. Okay, I'm almost there. How am I going for time? We're just a little bit, I was waiting for my warning. Okay, so I've got 2 slides to go. Okay, I'm going to go. Now, I promised I was never going to actually put a whole genome sequencing map on a slide for you. But this is really interesting. This is one of those plasmids that Pat mentioned. This is a superbug plasmid. It has resistance to 9 or 10 antibiotics, and they're all here in this one little region of the plasmid. Where do we get this plasmid from? Is it from a human? No. Is it from a livestock species? No, it's from a cat at a cat shelter in Sydney. This poor cat developed mucohemorrhagic diarrhoea. It went to the local vet, they cultured the salmonella from it, oh my God, it's a multi-resistant strain, the like we've never seen before. It is resistant to carbapenems. And the carbapenem resistance gene it has is the same one that's circulating amongst humans in Australia and Southeast Asia. Where did it come from? Well, this is actually two plasmids superimposed on one another. They are almost exactly the same. The second plasmid comes from China, from humans. So I think we haven't got the smoking gun there, but why is that plasmid being maintained when we don't use carbapenems in companion animals? And how has it turned up in that area? Well, we think we've got the answer here. These are all heavy metal resistance genes, and we've shown that one of those is arsenic. This bug is resistant to arsenic. Around the Sydney area, we've got old arsenic dips, so we can see plasmids being maintained purely by a non-antimicrobial type alternative. So the bug is surviving in an arsenic-rich environment in that area. That's a worry for me. We don't want this plasmid ending up in our food animal isolates, so we'll go from there. Okay, so in conclusion, I just wanted to say that we see resistance to critically important drugs. We see them more in companion animals than we see in livestock. We're just starting to see them emerge in livestock. And remember that fluoroquinolone-resistant isolate that was also resistant to ceftiofur, the one single isolate that we mentioned? Well, those isolates were first seen, nearly 20 years ago in the USA, so we're starting from a very low base. That single isolate, when we sequenced it, once again, lo and behold, its closest match comes from Southeast Asia, where it's commonly moving between humans and animals. How it ended up in Australia, we have no idea yet, but we want to find out. These new technologies, I think, will be a great tool for us, but I think they'll be a great marketing and promotion tool for high-quality, clean, green Australian pork, and I think the future is going to be very bright because we've been very careful so far, we've got a great industry, and we're working incredibly closely and well in Australia with our medical counterparts, and they're starting to learn the message that we're part of the solution. We're a small part of the problem, but we're a very important part of the solution. And with that, I'll answer some questions.
Are people desperate to get to lunch? Because we can let you go, but if you're happy to wait, we'll have a few questions. Any questions?
For those of you who don't realise, these two guys are the livestock associated MRSA boys. Just like a typical staphylococcus, they form a cluster.
Yeah, that's true, I think. All right, I will just refer to Dr. Davies' presentation where he mentioned one of the claims from Europe which reduced 50% of the antimicrobial usage in livestock, but it had very little impact on detection in human infection.
Yeah.
So by monitoring or reducing the antibiotic usage in livestock here or in piggery, what are we aiming to? Or do we really want to reverse the resistance, which would be very hard because, in the last 10 years, Europe, the antibiotic resistance coming out, the usage coming this way, but the resistant gene going straight? Or do we really want not to see any more surprises, like more resistant genes?
I mean, there's definitely been some bad antibiotic practices in livestock areas. We can think, for example, the injection of XNL into every day-old embryo to prevent septicemia in poultry. That was done in a few regions around the world. We can see the way antibiotics have been sort of abused because of lack of education in developing countries. So there's always those indications. But I think for us, it's more of it's a PR point of view. I keep trying to say you can't go, okay, antibiotic free, that's organic. If you want to produce organic, you can, but it's a very small market and it's not going to feed the world, and we can't do it with the space that we can. I think the secret is to be saying we want to preserve the lifespan of our drugs. We want to be using as little as possible, but as much as necessary to promote animal health and welfare and produce a good, safe product. I think up until now, because we haven't really looked, we've been very lucky and we've been very complacent. I think we're only just realising now that if people want to make an ethical choice, you can be cynical and say, well, 50% reduction in antibiotics, hasn't made any difference to the human health scenario. But people feel better about eating a product if you're doing that. Also, a lot of the pig veterinarians have shown very effectively that you can increase your profit margins by reducing your reliance on in-feed antimicrobials. So I think it's a very complex story. and we might work in some very specific areas, but I think the overall policy of saying we want to try to reduce as much as possible without actually having disease outbreaks and things like that, I just think it's a win-win situation no matter which way you look at it. Whether or not the science, in 5 or 10 years' time, and we're still seeing the same level of resistance in humans, well, at least we haven't invested as much money and effort as they have in Europe to actually not solve the problem, you know. And a lot of the people I talk to in Europe are very worried that their governments have you know, and they're trying to tell the rest of the world, this is the way to do it, this is the way to do it. I think we can be a bit smarter in Australia. We're the last country to really come on with a regular surveillance program. And that's what, you know, we just knew that the Department of Agriculture and the industry couldn't afford $200 an isolate. We had to do it cheaper, we had to try to do it better. And that's where I see it in the future. I just see it as a win-win. Could I be cynical and say that, well, we're really doing it for a public relations exercise? Well, we've got everything to gain and nothing to lose if we do it that way. If we're found to create a resistance issue, boom, we know what happens. The babe effect happens, people drop in their consumption. Just look at what happened with the lettuce outbreak with salmonella. We work with a company, that's doing that. It doesn't matter that their company wasn't involved in the outbreak. All lettuce sales plummeted. You know, millions of dollars of stock was lost in that area, and that's why the industry gets scared, and that's why they want to try to manage the media relationship, because you know, people have great difficulty dealing with complex concepts, but they're very good at going onto a meme of, oh, antibiotic use in animals is really bad, and it's really bad for human health, therefore I won't eat meat.
Thank you, I'm really sorry, we're going to have to pull it up there. Darren will be out at